All right, welcome to Math. Mr. Jorgens here, ready for section 7.4 on the zero product property. This is a part one. We'll be doing a part two next time. So stay tuned and be ready to answer some questions along the way. All right, so what the zero product property is it's a rule that says if we have two numbers that multiply to make zero, then at least one of those numbers must be zero. And so what this kind of looks like in symbols is if A multiplied by B equals zero. So we have two numbers multiplied together. I'm going to say number times number equals zero. Then either this number has to be zero or that number has to be zero. So the way we would say that in math symbols is if A times B equals zero, then A equals zero or B equals zero. So if we have two numbers that multiply together to make zero, either the first number has to be zero or the second number has to be zero, or they're both the same number and they're both zero. So that's the zero product property. If we ever have two numbers that multiply together to make zero, then at least one of those numbers must be zero itself. All right, so the way that we're going to apply this rule in an algebra class is we're going to be looking at some equations where you're multiplying two quantities together and it equals zero. And we're going to know that either the first quantity is zero or the second quantity is zero. For instance, on this one, I'm multiplying x plus 1, the first quantity, multiplied by x minus 2, the second quantity. That's equal to zero. So if I'm multiplying the red times the blue, I'm going to know that either the red has to be zero or the blue has to be zero. Because if I ever multiply two quantities together and it gets zero, then one of those two quantities must be zero itself. So the way I kind of show that algebraically is I'm going to put like a little dash there. And then what I'm going to say is x plus 1 equals 0. And then we kind of think of the dash as or x minus 2 equals 0. Because either the red is 0 or the blue is 0. And what that does is it sets up two mini equations for me to try to solve. So the first mini equation, I'll start with the red, is x plus 1 equals 0. And I would solve that for x by undoing add 1 by subtracting 1 off of both sides. 0 subtract 1 makes negative 1, so x equals negative 1 would be the first option. And again, these mini equations aren't hard to solve. My second mini equation, the blue one, I have to undo a subtract 2, and I can undo subtract 2 by adding 2. And 0 plus 2 is 2. Sum with x equals 2. So what I kind of found out is that my two options to make 0 are x equals negative 1 and x equals 2. And if I kind of check that by plugging it in, if I plug in a negative 1, I'd have negative 1 plus 1 multiplied by negative 1 minus 2, which would give me negative 1 plus 1 would make 0. Negative 1 minus 2 would make negative 3. And 0 multiplied by negative 3 is 0. As soon as one of those numbers is 0, I know it's going to multiply to 0. And then for the other one, I would have 2 plus 1, which is 3, multiplied by 2 minus 2, which is 0. And 3 times 0 is also 0, right? So my other check is going to make 0 as well. All right, let's try one more similar problem here. So I'm just going to call this example 1b. We're going to be looking at x minus 7 multiplied by x plus 5 equal to 0. And again, on this example, I have two quantities that are multiplied together. I'll call them the red quantity and the blue quantity. Whenever I have two quantities multiplied together equal to 0, then I know that either the first one must be 0 or the second one must be 0. So I can draw on my dashed line to show my work here. I know either the red equals 0 or the blue equals 0. That's kind of my setup here. So I know either x minus 7 has to be 0 or x plus 5 has to be 0. And if we think about the check, the reason why we'd want to do it this way is in problem A, x plus 1 equal to 0, we kind of showed that right here, right? And if that first number is 0, I know it's going to multiply to 0. Same thing with the second one. If I make this x minus 2 equal to 0, then I know that that second one is going to multiply out to 0 in the check, right? So if I go to solve out the first mini equation, I can do it by adding 7 to both sides. And I get x equals 7. If I think about solving out the blue, that second mini equation, I can solve it by subtracting 5 off of both sides. So I get x equal to 0 minus 5 is negative 5. So that's kind of the main strategy behind the zero product property here. There's really only one case of this that looks a little different, and example 2 is going to cover that. And that case is x times x minus 4 equals 0. And the reason why is when I think about this as a multiplying problem, what I really have is I have the red quantity multiplied by the blue quantity. And so I have the red number multiplied by the blue number equals 0. And so I can either set the red equal to 0 or the blue equal to 0. So either x equal 0 or the blue x minus 4 equals 0. So kind of the tricky part is to be able to set it up where you have, that x number directly equal to 0. There's not like parenthesis parts, so people get confused by that. So the first one, there's actually like no work. It's just automatically like x equals 0 is our first answer there. And then it's only the second one, x minus 4 equal to 0, that you have to solve out. So go ahead and solve that blue equation for x and enter your answer when you're ready. So if we added 4 over to the other side, x equals 4. So our two answers for this one in terms of the zero product property would be x equals 0, which would make the first number 0, or x equals 4, which would make the second number 0. I'm going to call that example 2a. Go ahead and try example 2b, x times x plus 6 equals 0. So go ahead and solve that one out using the zero product property and enter your answer when you're ready. So again, we get that first one, x equals 0 automatically. The other one, we have to subtract the 6 over to the other side, get x equal to negative 6. So hopefully you got that 0 and negative 6 as your answers. All right, we got a couple try three. We're going to try 3, but we're going to have a couple try these problems at the end here we're going to work through. We're going to kind of work through them one at a time. The first one is x plus 1 times x minus 2 equals 0. So go ahead and work through that one. Find the two numbers that could make that 0 and enter your answer when you're ready. So hopefully we got x plus 1 equal to 0, which then when I subtract the 1 over, I get x equal to negative 1. And x minus 2 equals 0, which when I add the 2 over, it's going to add to positive 2. So negative 1 and positive 2 on that one. So that's kind of my first problem here. My second one we're going to try is x minus 3 times x plus 10 equal to 0. Go ahead and try that one. Work it out. Enter your answer when you're ready. All right, so on this one, I get x minus 3 equal to 0, which when I add the 3 over, I get x equals positive 3. And then I have x plus 10 equals 0 as that second quantity. And when I subtract my 10 over, I get x equal to negative 10. So 3 and negative 10 are our quantities there that work for the zero product property. Last one, x minus 5 times x minus 2 equals 0. Go ahead and work that out using the zero product property and enter your answer when you are ready. All right, so we have x minus 5 equal to 0 and x minus 2 equal to 0. I can solve both those mini equations by adding my 5 over to the other side. And I get x equal to 5. And then for that second mini equation, I'm going to add my 2 over to the other side. I get x equal to 2. So if we have an understanding of how the zero product property works here, should be ready to try that big ideas set now. Thanks for staying tuned, and I'll see you next time.